Welcome back, everyone, to Data Science for Everyone. Today, we're going to be talking about practical error handling and debugging in JavaScript. Let's get started. So, effective error handling and debugging are not just technical tasks. They're essential practices that ensure the reliability, security, and user experience of software that supports critical business functions. Today, we're going to explore how to approach bugs and errors in business software development, emphasizing the practical examples and strategies tailored to these real-world business scenarios. So first, we need to understand the business applications and what the bugs entail. So bugs can fall into two different categories, and the first one is in order to address them. So one is logical bugs. These occur when business logic implementation in a program does not accurately reflect the intended operations or rules in the business. So an example here might be an e-commerce platform incorrectly calculating discounts. Now we also have a technical bug, and these are the errors in code that cause the program to behave unexpectedly or fail. So one example of this could be that you have a payment processing system that might crash due to an unhandled exception when a network request times out. So we want to be able to prioritize certain bugs. Okay, so what in the business context? So if we prioritize certain bugs, that's going to be based on the impact. We want to decide which bug needs immediate attention and which one can be scheduled for later. Another idea is identifying the impact, assessing how the bug affects the business operations and the user experience. And again, from there, we can prioritize them. So one thing that we need to talk about is JavaScript's flexibility. That can be a blessing and a curse. Its dynamic nature allows us for rapid development and iteration, but it also leaves room for errors. So one thing that we need to be able to do is think about utilizing strict mode to help us catch common coding mistakes in early development. So when we do this, we set up, in quotes, use strict. Okay. And so here in this example, let's consider creating up the purpose of it. Let's actually put that up here. So we're going to enforce data integrity with strict mode. Okay. So in the system, we're going to consider a payroll system where the calculation of salaries must be precise. So by enabling strict mode, this is going to help us catch any common mistakes that are in our development process. So let's go on and create up a function. And we want to calculate payroll, and we're waiting for employees. We have some employee data. So let total payroll equal 0. And then we're going to loop through for I, and here we want to edit this up here to be employees. So maybe this is going to be some list of employees. Okay, and we want the length of the employees. And then here, instead of this const element here, we want to ensure variables are declared. This prevents accidental global variables. So let salary equal calculate salary. And again, we want our employees here, and we're going to grab at some I. Okay, then we'll do total payroll plus equals their salary. All right, and then eventually we'll want to return our payroll, specifically our total payroll here. All right, so let's go in and maybe give this a run. So let's do something like, not return. We want our calculate payroll, and 1, 2, 3. And again, this calculate employee salary isn't actually created up anywhere, so we may run into an error. So let's give that a try and see what happens. So let's refresh this. Uncaught reference calculate salary is not defined. Okay, so we have this error popping up saying, oh, this isn't defined, and it's causing us some problems. So as we can see, this, again, calculate salary is not defined, okay? But what I'd like to do is actually go back over here, and I want to show you this. So let's remove this let, okay? And if we go back here and we refresh now, oh, uncaught reference ID is not defined. So notice here that it stops us at this I, because I here is not defined. If we go through and I put in let, it'll go back down through and it will catch this error here. And we can see that it will move on, all right? So now this is not defined because again, it knows that this particular function isn't defined anywhere inside there, and it's giving us an issue. So we can always just mess with it and just give it a 4 or something to play with this, and let's run it now. All right, so now there are no errors, but let's say that we go through and we forget this let again over here, and we refresh. Notice salary is not defined, and again, it's giving us that calculation. Now, if we notice that let is there, but if we remove this, use strict, and come back over and I refresh this, notice it does not give us any errors coming out here, okay? So that is a big issue, all right? So we want it to be able to throw out an error if there's any potential for common coding mistakes. And again, that happens when you use this use strict. So the next type of thing that we would want to look at is robust type handling and testing. So let's go in and comment this out for now, and we can give up another example here in a second. So given that business logic often involves data manipulation, ensuring that data types are properly handled correctly is crucial. So automated testing becomes a vital tool in this context. This allows developers to verify that business rules are correctly implemented and maintained throughout the software lifecycle. So let's look at some business logic. An example might involve testing a function that applies tax rates to transactions in a financial application. So let's do FinApp. And so let's have a function. And this is going to be test apply tax. And it's not going to take anything. And we'll say let transaction is some amount, say 100, tax rate, let's say 0.2. So expected tax is 20%. Let result equal to our some function apply tax of some transaction, and we'll say this is if result does not equal 120. Here we want it just to console log out test failed, application incorrect. Okay, and so actually instead of just this function of apply tax, because we haven't actually created some function that does that, let's just say transaction dot amount multiplied by transaction dot tax rate. All right, and let's go on Let's say test, apply tax. Uncaught error, L is not defined, so let's actually find where that L is. Whoops, L is right here. Let me zoom out just a little bit for you so you guys can see. All right, test failed, tax application incorrect. Well, why did that happen? Well, it's because technically this isn't doing what we would want it to do. Okay, so if we actually have it so that the actual result is, let's actually just hard code it to 120. Okay, and run this. Notice nothing came out. Okay, because again, this doesn't actually do the calculation that we want it to do. Okay, this is not what is going to happen. Okay, so if we would want to fix this, we could do something like this. So again, if we remember, calculating up a proper tax rate, we would actually want this. Whoops, let's move you over. It would be 1 plus this tax rate. Okay, so now if we run this, again, notice we don't get an error. And let's say maybe we put this as 0.1 for some reason, some accidental error there. We run it, notice test failed, tax application incorrect. So having these tests in there so that we know what this should be for certain test values, that's going to help us be able to know when functions aren't doing what they're supposed to be doing. So the next thing is we have some error handling strategies for business. Now, business software often gracefully handles errors and ensures the system's reliability is paramount. This might involve sophisticated error recovery strategies, such as transaction rollbacks in a database system, or maybe user-friendly error messages in a customer-facing application. Now, we also have graceful degradation. So implementing a fallback mechanism in case of failure, such as using cached data when a live data source is unavailable, ensures that the application maintains functionality under various conditions. So we can use exceptions effectively. So exceptions can be used to handle errors that are unexpected and often outside of normal operation. So such as failing to connect to a critical external service like a payment gateway. So let's comment this out. Let's create up another example here. All right. So let's say that we are handling a payment exception. Okay, so we can use the try and catch method. All right, so here, inside here, we could say something like process payment for some order. And then if there's an error, we can log error of the error, whatever that message is. And this is log for auditing purposes. Okay, and then we can alert the user here. Payment processing failed. Please try again, or contact support. Okay, so let's go on and give this a try. We can refresh this. Log error is not defined, so maybe we can actually just do something like this. Let's change this just to alert. Okay, so here it actually pops out, reference error processing payment is not defined. We can hit OK. Uncaught reference error, alert user is not defined. So again, here we could also do just say something like alert, and maybe which changes just to console.log for now because we don't actually have these functions created up. So we can run this again. Notice this page says payment processing failed. Please try again or contact support. And again, here it has this process payment is not defined because it's having this error. Well, process payment is definitely not defined. Now, if we wanted to just say something like, I don't know, console log 2 plus 2, well, none of this should be coming out, okay? So if we go back over here to something that actually works, we refresh it, notice 4 comes out, but none of this error messaging because no error actually popped out. So that's using the try and catch, and we've seen that in other examples on the channel before. So we can also do selective catching and assertions. So selective catching allows handling specific types of errors that are anticipated in some business logic, while assertions can be used to enforce critical invariance within the system. So we could, in theory here, say something like function. Oh, you know what? Let's actually give this a name here. So asserting business constraints. Okay, so let's create up a function. And we'll call this add inventory item. It's going to take some item. No, we want it to take some item. All right, so if not item dot price or item dot price is less than or equal to 0, we want to throw a new error, assertion failed, item price must be positive. Okay. So if we go in here and we do add inventory item and we give this price of, let's say 0. Fresh, uncaught, error, assertion failed, item price must be positive. So if we went through in here and we put in 2, and we refresh, notice nothing comes out now. So we can give these nice, so let's actually, maybe someone accidentally put in a -2 inside of the price. Notice uncaught error, assertion failed, item price must be positive. So again, these are very useful to add in certain business constraints and again, just basic logic inside of the code for any type of user error. So in conclusion, what we've seen inside of this business software development is effective error handling and debugging go beyond technical correctness, directly impacting the bottom line and customer satisfaction. By employing strict mode, rigorous testing, and structured error handling techniques, developers can create more reliable, maintainable, and user-friendly business applications. These practices not only help in identifying and fixing bugs, but can also be used to prevent them. This ensures that business operations run smoothly and efficiently. If you guys like this content and you want more of it, please comment, subscribe, and hit that like button. I will see you guys next time. Bye-bye.